Alright, this video is going to go over double angle and half angle formulas. What we mean by double angle is, say, a formula for the sine of 2 theta. Likewise, there comes formulas for cosine of 2 theta and tangent of 2 theta, as well as sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. Now, we can come up with the formulas for these, at least for the sine and cosine and tangent, by using the angle sum formulas. Alright, for sine of 2 theta, we begin with rewriting it as just sine of 2 theta equals sine of theta plus theta. And let me go ahead and put a nice screenshot up here that'll be a lot easier for you to read than my handwriting. Alright, so if we rewrite sine of 2 theta is just sine of theta plus theta, then we can use the angle sum formula written here and just replace alpha and beta with theta, so sine of theta times cosine of theta plus cosine of theta times sine of theta, so that gives you 2 sine of theta cosine of theta. So this is the formula for sine of 2 theta. We just got it by plugging in theta for both alpha and beta, and that gives you sine of 2 theta. Likewise for the cosine of 2 theta, alright, we know that the angle sum formula for cosine is cosine of alpha times cosine of beta plus sine of alpha times sine of beta. So if we replace alpha and beta with theta, we'd get cosine of 2 theta equals cosine squared minus sine squared. Now, one thing I want to remind y'all about is sine squared of theta plus cosine squared is equal to 1. So remember, sine squared of theta is equal to 1 minus the cosine squared. Likewise, cosine squared is equal to 1 minus the sine squared. So if you were to substitute in 1 minus sine squared for cosine squared, you'd have cosine of 2 theta equals, instead of cosine squared, it'd be 1 minus sine squared, and then minus sine squared again. So we could rewrite this formula as just 1 minus 2 sine squared of theta. Likewise, the sine or cosine of 2 theta. If instead we substituted 1 minus cosine squared for sine squared, that'd be cosine squared of theta minus, and then since we're subtracting, we would need to put it in parentheses, 1 minus cosine squared of theta. So if we plug this in, or not plug it in, if we distribute the minus, it'd be cosine squared of theta minus 1 and then plus cosine squared again. So we could also rewrite the formula for the cosine of 2 theta as just 2 cosine squared of theta minus 1. Now here's a nice list of the double angle formulas for sine and cosine. Nice, neatly written out. We're going to do a couple of examples of how we would use these. Alright, in this example of sine of theta is equal to 3/5 with theta ranging from pi over 2 to pi, find the exact value of sine of 2 theta and cosine of 2 theta. Now remember, sine of 2 theta is equal to 2 sine of theta cosine of theta. So we would need to figure out the value for cosine. Remember, theta is from pi over 2 to pi, so it's in the second quadrant. And sine of theta is 3/5. Remember, sine is equal to y over r. So our hypotenuse is 5, and our y value is 3. So if you want to do Pythagorean theorem, x squared plus 3 squared equals 5 squared. So x squared plus 9 is equal to 25. x squared is equal to 16. And that tells us that since we're in the second quadrant, we'd want the negative square root, so x would be negative 4. So now, cosine of our angle theta would be negative 4 over 5. So, if we want to plug everything in, 2 times sine, which is 3/5, times cosine, which is negative 4/5, that would give you 2 times 3 is 6, times negative 4 would be negative 24 over 25. That's for part A. Now, for part B, cosine of 2 theta. It doesn't matter which formula you use. You notice you're given 3 different formulas. You could use either of them. So, since we already have the sine, since we were given the sine originally, I'm just going to use 1 minus 2 sine squared of theta. You could easily use cosine squared minus the sine squared. It doesn't matter. Regardless of which formula you use, you should always get the same value. So it'll be 1 minus 2 and then sine squared, so that'd be 3/5 squared. It'll be 1 minus 2 times 3 squared is 9 over 5 squared is 25. So that'd be 1 minus 18 over 25. And remember, 1 is equal to 25 over 25 minus 18 over 25, which would be 7 over 25. Alright, here's another example. It says develop a formula for tangent of 2 theta in terms of tangent of theta. And also develop a formula for sine of 3 theta in terms of sine and cosine. So for part A, let's remember the formula for the tangent of alpha plus beta. Now use the same general process as the other 2 formulas, sine of 2 theta and cosine of 2 theta. Alright, to remind you, our formula for tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta over 1 minus tangent of alpha tangent of beta. So if we replace alpha and beta with theta, that would give us tangent of 2 theta equals tangent of theta plus tangent of theta in the numerator, so 2 tangent of theta, all over 1 minus, now tangent of alpha times tangent of beta, that becomes tangent of theta times tangent of theta, which would be tangent squared of theta, and there's our answer. Alright, and now for part B, it says find a formula for sine of 3 theta in terms of just sine and cosine. Remember, sine of 3 theta we can rewrite as sine of 2 theta plus theta. So, we could use the angle sum formula. So it would be sine of 2 theta times cosine of theta plus cosine of 2 theta times sine of theta. So sine of 2 theta is equal to 2 sine of theta times the cosine of theta multiplied by the cosine of theta plus cosine of 2 theta. Depending on which formula you use, you could use cosine squared minus sine squared times the sine. So that's equal to 2 times sine times cosine. Just if you multiply in, that'd be 2 sine of theta. Now cosine times cosine would be cosine squared. Plus, now if you distribute this sign on the end, that would be plus sine of theta cosine squared, sine theta cosine squared of theta. And then minus sine squared times sine would be sine to the third. Now if you want to combine like terms, you have a 2 sine theta cosine squared plus sine theta cosine squared, so that would be 3 sine of theta cosine squared of theta minus sine to the third of theta. Now, let's go back to the formula we have up here. Now remember, there were 3 different formulas for cosine of 2 theta. Depending on which of those formulas you use, you'll get a different answer. So, likewise, had you substituted in, instead of cosine squared minus sine squared, if you had done 1 minus 2 sine squared of theta, you would have ended up with you would have ended up with 2 sine of theta cosine squared of theta minus 2 sine squared of theta, because you would have distributed the sine into here into the minus 2 sine squared. And then you would have had to distribute the sine on the end to the positive 1, so that would have given you the plus sine of theta on the end. Now, had you instead decided to use 2 cosine squared of theta minus 1, the third formula, then you would have ended up with, you would have had 4 sine of theta cosine squared minus sine of theta. Because the sine on the end would have been distributed to 2 cosine squared of theta, so you would have had 2 times sine times cosine squared. Add it to this 2 sine cosine squared, and that would have given you the 4 sine cosine squared. Then distribute the sine on the end to the minus 1, that's where you get the minus sine of theta on the end. So depending on which formula you use to substitute into cosine of 2 theta, you have gotten any of these 3. Alright, so now we're going to go over alternate formulas for sine squared and cosine squared and tangent squared. Now, you know that sine of theta, or sine squared plus cosine squared is equal to 1. So sine squared is equal to 1 minus cosine squared. Also, cosine squared is equal to 1 minus the sine squared. Likewise, if we were to divide this entire equation by cosine squared, you'd have sine squared over cosine squared, which is tangent squared, is equal to, if we divided by cosine, it'd be 1 over cosine squared, which would be secant squared. Then cosine squared over cosine squared is 1. Now, we're going to come up with 3 alternate formulas for sine squared, cosine squared, and tangent squared besides these 3. Alright, if we take the formula for cosine of 2 theta, the one that's equal to 1 minus 2 sine squared of theta, and we get the 2 sine squared by itself, we'd have 2 sine squared of theta is equal to 1 minus cosine of 2 theta. Divide everything by 2 to get the sine squared by itself, and you'd have that sine squared of theta is equal to 1 minus cosine of 2 theta all over 2. Likewise, take the formula for cosine of 2 theta is equal to 2 cosine squared of theta minus 1. Again, if you follow the same procedures, get the 2 cosine squared of theta by itself, you'd have 2 cosine squared of theta is equal to cosine of 2 theta plus 1. So, divide everything by 2. You have that cosine squared of theta is equal to cosine of 2 theta plus 1 all over 2. Now, for tangent squared of theta, that's equal to sine squared over cosine squared. Then that's equal to, remember, sine squared is equal to 1 minus cosine of 2 theta all over 2. cosine is equal to 1 plus cosine of 2 theta, or cosine of 2 theta plus 1, it doesn't matter which order, in what order you write it, over 2. Either way, if you do keep flip change, flip the denominator and multiply. The 2's cancel out. So tangent squared of theta is equal to 1 minus cosine of 2 theta all over 1 plus cosine of 2 theta. Alright, write an equivalent expression for cosine to the fourth of theta that does not involve any powers of sine or cosine greater than 1. So what we can do is use those formulas we just created, or just wrote. Cosine to the fourth of theta is equal to cosine squared of theta squared. What you could take is that formula for cosine squared of theta. So you'd have cosine of 2 theta plus 1 over 2 squared. Now, this 2 on the bottom is squared, so you can rewrite that as 1 to the fourth, and then cosine of 2 theta plus 1 squared. So that would be 1 to the fourth, and then if you were to FOIL this and expand it, it'd be cosine squared of 2 theta and then plus 2 cosine of 2 theta plus 1. Now we still have a cosine squared, so we need to get rid of it. Remember, the formula we just wrote, cosine squared of theta is equal to 1 plus cosine of 2 theta all over 2. Well, we can use that same formula for this, just everywhere there's a theta, right? 2 theta. And we could use it. So, this would be equal to 1/4. And then cosine squared of 2 theta would just be 1 plus the cosine of 2 times 2 theta. Because remember, it's 2 theta on the inside, so everywhere there's a theta, we have to plug in 2 theta all over 2 plus 2 cosine of theta, or 2 cosine of 2 theta plus 1. So now, if we want to distribute everything, distribute the 1/4 in, that would be equal to 1/4 times this 2 on the bottom, this pretty much to multiplying by 1/2, 1/4 times 1/2 would be 1/8 times 1 plus cosine of, that ends up being 4 theta, plus 2 times 1/4 would be 1/2 cosine of 2 theta. And then 1/4 times 1 would be 1/4. Distribute the 1/8 into here. We have 1/8 plus 1/8 cosine of 4 theta plus 1/2 cosine of 2 theta plus 1/4. Now 1/8 plus 1/4. Remember, 1/4 can be rewritten as 2/8. 2/8 plus 1/8, that's 3/8. Plus 1/8 cosine of 4 theta. Plus 1/2 cosine of 2 theta. And look, we now have powers of cosine to the first power. It's not like cosine squared or cosine to the third or anything, so we're done. So for this example, let's solve this trig equation. Solve this equation, sine times cosine equals negative 1/2 from 0 to 2 pi. If you notice, if we multiply it by 2, we have 2 cosine of theta, or 2 cosine of theta times sine of theta. It doesn't matter which order in which you multiply them, is equal to negative 1. Now we know 2 times sine times the cosine is sine of 2 theta, so we could rewrite it as sine of 2 theta is equal to negative 1. Now, sine is equal to negative 1 on this interval at 3 pi over 2. So, the stuff on the inside, 2 theta, has to be equal to 3 pi over 2. Plus 2k pi. Because we're going to find the general equation for theta, and then we're going to use that to determine any angles on this interval that meet this equation. So, if we solve for theta by multiplying everything by 1/2, the 2's would cancel out. If we're multiplying by 2 here, that'd be 3 pi over 4 plus k pi. The 2's cancel out, so you're left with theta is equal to 3 pi over 4 plus k pi. So when k is equal to 0, our angle theta would just be 3 pi over 4. So, sine of 3 pi over 4 times cosine of 3 pi over 4 Now in that quadrant, I believe that falls in the second quadrant. In the second quadrant, the sign is positive, so it would be sine of 3 pi over 4 is equal to square root of 2 over 2. The cosine is negative, so it would be negative square root of 2 over 2. So your product would be negative, and it'd be 4 on the bottom. And then square root of 2 times square root of 2 is just square root of 4, which is 2. So that would be negative 1/2. So that works. So one of our thetas is 3 pi over 4. Now let's keep going, because there might be other angles on that interval from 0 to 2 pi. Say k equals 1. That tells you that our angle would be 3 pi over 4 plus 1 times pi, which is just pi. So, remember, pi can be rewritten as just 4 pi over 4. 3 pi over 4 plus 4 pi over 4 is 7 pi over 4. So now let's plug that in. Let's plug that into our formula. So sine of 7 pi over 4 times cosine of 7 pi over 4. Remember, 7 pi over 4 is in the fourth quadrant. In that quadrant, the sign is negative, so it'd be negative square root of 2 over 2 if you look at your unit circle, times the cosine. Remember, cosine is positive in the fourth quadrant, so it'd be positive square root of 2 over 2. So you'd end up with negative square root of 2 times square root of 2, we said was 2, over 4, so it's negative 1/2, so that works. So, our solution set would be the set of angles 3 pi over 4 and 7 pi over 4. Alright, here's another example. It says an object is propelled upward at an angle theta to the horizontal with an initial velocity of v sub 0 feet per second. If air resistance is ignored, the range r, or the horizontal distance, is given by the function 1 over 16 times the initial velocity squared times sine of theta times cosine of theta. First question says, show that that function can be rewritten as just 1 over 32 times initial velocity squared times sine of 2 theta. Now, if you notice we have a sine theta times cosine of theta, so our formula for part A, we could rewrite as 1 over 16 times v sub 0 squared, and then that we could rewrite as just 2 sine of theta times cosine of theta over 2. Because remember, 2 times sine times cosine over 2, the 2's would cancel out, so you'd still have what you started with up here. And the reason we did that is because we know that 2 times sine times cosine is sine of 2 theta over 2 times initial velocity squared times 1 over 16. Now you have this sine of 2 theta over 2, you can multiply the denominators together, so you have 1 over 32 times v sub 0 squared times sine of 2 theta. And that's how we know that we can rewrite our formula as this. Now for part B, it says show the angle for which r is a maximum. Now we know the angle's we know that sine, our trig function, is at a maximum. When our sine is equal to 1. Because remember, the sine value alternates between 1 and negative 1. So if we know that our value for sine has to be equal to 1. And we know that on the range from 0 to 2 pi, it's equal to 1 at 90 degrees. But our input is 2 theta, so 2 theta has to be equal to 90 degrees, which means our angle has to be 45 degrees. So, neglecting wind resistance, the angle that will give a maximum velocity, or a maximum distance, would be 45 degrees. Now we will go over the half angle formulas. Alright, we start off by taking those formulas for sine squared, cosine squared, and tangent squared we created, and we just plug in an angle divided by 2. Like so. We have if we plug in sine squared of alpha over 2, instead of cosine of 2 theta, if instead we plug in alpha over 2, we'd have 2 times alpha over 2. The 2's would cancel out, so that's how we end up with just cosine of alpha. Likewise here, that's how we got these. That's why it's not cosine of 2 theta, why it's just cosine of theta, or cosine of alpha. So, if you take the square root of both sides of each of these equations, you get the half angle formulas. So whenever we take the square roots, we get the following formula. Sine of alpha over 2 is equal to the positive or negative square root of 1 minus cosine of alpha over 2. Likewise, cosine of alpha over 2 is equal to the positive or negative square root of 1 plus the cosine of alpha over 2. And tangent of alpha over 2 is equal to plus or minus the square root of 1 minus cosine over 1 plus cosine. And we take the positive or negative square root depending on which quadrant our angle alpha over 2 is in. Alright, here's one way we would use the half angle formulas. Alright, cosine of 15 degrees for part A. We know that would be 30 over 2. I don't know why I wrote 3 theta, it's supposed to be just 30 over 2. Now, we know this 15 degrees is in the first quadrant, so we'd use the positive square root. And then that'd be 1 plus cosine Our alpha is 30, so 1 plus cosine of 30. And I did it again, wrote 3 theta. Cosine of 30 degrees all over 2. And cosine of 30 degrees, I believe, is square root of 3 over 2. All over 2. Alright, and 1 can be rewritten as just 2 over 2 plus square root of 3 over 2. All over 2. So that can be rewritten as just square root, or 2 plus square root of 3 all over 2. Combine the numerator into one fraction, divide by 2. So that can be rewritten as square root of 2 plus square root of 3. And then we can divide the denominator by whatever we're dividing by, so it'd be over 4. Take the square root of the top and bottom separately. So it'd be square root of 2 plus square root of 3. And the square root of 4 is just 2. Alright, so now for part B, sine of negative 15 degrees. There are 2 different ways we could go about it. If you don't want to deal with the negative angle, you know sine is an odd function, so you could just move the negative to the outside, so negative sine of 15 degrees. And 15 degrees, we already said, could be rewritten as just sine of, we said it could be written as 30 over 2. Now, 15 degrees is in the first quadrant, so we technically take the positive square root, but we have a negative sign in front. So if we take the positive square root, it would be 1 minus cosine of our alpha, which is 30 degrees, all over 2. Then we gotta put our negative in front. And that's equal to negative square root of 1 minus 30. We already said it was square root of 3 over 2, all over 2. If you notice, this looks awfully similar to part A. It's just that the sign underneath has been switched, and it's negative on the outside. So it'd be negative. And if you want to use the same work as before, so you don't have to work through all that again, you could just say it's equal to negative square root of 2 minus the square root of 3 all over 2. Alright, cosine of alpha is negative 3/5 with our angle alpha being from pi to 3 pi over 2. Find the exact value of sine of alpha over 2, cosine of alpha over 2, and tangent of alpha over 2. Now, our angle is in the third quadrant, which means our sign would be negative, so we're looking for the negative square root of 1 minus cosine of 2, or 1 minus cosine of alpha, over 2. Our alpha is negative 3/5, so it's square root of 1 minus negative 3/5 over 2. Remember, this is for part A. So that would be negative square root of, if we add, that'd be 1 plus 3/5 would be 8 over 5 divided by 2. So that'd be negative square root of 8 over 10, which would be negative square root of 4/5. Now, since we have a fraction, we can take the square root of the top and bottom separately, so that'd be negative. Square root of 4 is 2, and we have square root of 5. But we don't like having square roots on the bottom, so we multiply by square root of 5. So that's negative 2 square roots of 5 over 5. Hold on. Let's check to make sure it would in fact be negative. We were told that alpha is between pi and 3 pi over 2. But we're not dealing with alpha, we're dealing with alpha over 2. So we need to divide everything by 2. So if we divide everything by 2, you know alpha over 2 is contained between pi over 2 and 3 pi over 4, which is in the second quadrant. Since we're in the second quadrant, the sign would be positive, so it would be positive 2 square roots of 5 over 5. Alright, for part B, cosine of alpha over 2. Remember, cosine is also negative in the third quadrant, so we want the negative square root of 1 plus cosine of alpha over 2. So it's negative square root of 1 plus negative 3/5 all over 2. So that would be negative 1 plus negative 3/5 would be 2/5 all over 2. And 2/5 divided by 2 would just be 1/5, because 1/2 of 2/5 is 1/5. So you can take the square root of the top and the bottom separately. So square root of 1 is 1, so negative 1 over square root of 5. Multiply the top and bottom by square root of 5, and that's negative square roots of 5 over 5 for part B. Alright, and something I just realized that I also did on the previous slide, I did it again for alpha instead of alpha over 2. So we know alpha over 2 is in the second quadrant. It's still negative, but you gotta make sure to keep in mind to compute it over alpha over 2 instead of just alpha. So now for part C, tangent of theta over 2. Now there are two different ways you could go about it. You could, since you know tangent would be positive in the third quadrant, since sine and cosine are both negative, dividing by negative is a positive. You could take the positive square root of 1 minus cosine of theta, or cosine of alpha rather. 1 minus cosine of alpha over 1 plus cosine of alpha. That's the long way to do it, although there is an easier way in this instance. Since we have tangent of alpha over 2. We've already computed sine of alpha over 2 and cosine of alpha over 2. So we could just divide those results and we could get our value for the tangent. So it'd be 2 square roots of 5 over 5 divided by square root of 5 over 5. If we do keep flip change, we'd have 2 square roots of 5 over 5 times 5 over square root of 5. And we would get, and that'd be negative and negative. I forgot the negative sign. So that'd be positive times a negative, so it'd be a negative. And then the square roots of 5 would cancel out, so it'd be negative 1 times 2 would be negative square root of 2. Alright, and another way to rewrite the formula for tangent of alpha over 2, if you don't like that square root function, is just 1 minus cosine over sine of alpha, or sine of alpha over 1 plus cosine of alpha. And here's why. Alright, now, we know that 2 sine squared of theta, or 2 sine squared of theta is equal to 1 minus cosine of 2 theta. So if we plug in alpha over 2, that's how we can rewrite this 2 and this alpha over 2, the 2's would cancel out, so that's how you end up with 1 cosine of alpha. And that's how you can rewrite this 2 sine squared of theta as 2 sine squared of theta over 2. Likewise, sine of 2 theta is equal to 2 sine over cosine. So, if you were to plug in just alpha over 2 into each of these, That's how you go from, like the 2 should cancel, that's how you go from sine of alpha to 2 sine of alpha over 2 times cosine of alpha over 2. Now, one of the sines would cancel out up here, and that sine would cancel out over there, so you have, and also the 2's would cancel out, so you'd have sine of alpha over 2 over cosine of alpha over 2, which is tangent. So, that's how we can rewrite tangent of alpha over 2 as this first formula. And if you multiply by the conjugate, 1 plus cosine of alpha, if you were to distribute then, you'd have 1 minus cosine squared. Which is just sine squared. So you have sine squared over sine times 1 plus cosine. One of the sines would cancel out on the numerator. So that's how you can rewrite that. Again, it's just sine over 1 plus cosine.